So we have all the components laid out here for the cartridge build. We have the ZIF socket, which I had to modify because it won't fit in the board without modification. This is the board itself from PCB Way! Two-sided board for the cartridge. It has to be two-sided, of course, because the cartridge is two-sided. 4 10K resistors. We have 2 diodes. 5 bank dip switches. A capacitor, which I think is 10 nanofarads, sorry, and 3 headers and some jumpers. Solder and clippers and masking tape are also essential equipment here. I do apologise for the focus. I only noticed this after because I am overdubbing this. Okay, let's get the resistors out and bend them. So yeah, I do apologise for the focus, but since I'm not monetizing and since this is the first time I've ever done anything like this, I'm going to use it as a learning experience. See if I can lock the focus off in the camera in the future. I'll bend the resistors, ready for placing onto the board. We have cats in the background, which is the little tinkly bells. So there will be pet noises, but that's a house of pets. Bend the diodes too. These are slightly different because they don't totally match the size, but it's nothing that's unmanageable, of course. Okay, we'll get these slotted in. These are pull-up resistors. They're in. Masking tape to keep them onto the board. Get the board holder. A bit fiddly setting up, but once it's set up it's quite easy to use. This part of the circuit is for 16K ROMs. It uses some diode steering, I believe. Oh yeah, I forgot a switch. We do a bit of magic later on with that switch. So you know, this is where it's a little bit fiddly, but yeah, it goes on. Here we got cat noises. The masking tape over here to keep them on again. Now here we are, setting this up. It's a bit tricky. Which way round do I put it? It's only a small board. Not totally necessary, but it does make things a bit easier. Ah, damn. Slipped. Right, get that closer. Lock it off and get them into place. This is a recent acquisition, this board holder. Okay, so straighten the pins out so we can solder. And we begin the soldering. If it looks a bit messy, that's because it is. I only realised after that I think I've been using the soldering iron a bit hot, and the the actual bit solder bit is damaged. I've changed it now, but it worked for this. It worked for this. Of course, no clipping sounds because, as I said, it's overdubbed. When I actually built the board, there was a lot of background noise, so I couldn't use it. There we go. Oh, we're trying to get some light on the situation here. It doesn't come out well on camera at all, so I give in. Try a different source of light. I do think I need new glasses for very close-up work like this, though. There we go. Remove the masking tape. On to the next bit, which is the capacitor. Less fiddly now it's already set up. Would help if I put it in the right way. Okay, solder the capacitor in, just no need for masking tape on this particular one. Snip. Not much to snip off with the capacitor. Keep them all there. I use them for perf board stuff. I hate working with perf board. Have I said that before? I'm very new to perf board. This isn't perf board. I'm used to circuit boards, but I'm not used to perf board. Okay, so now I'm getting the headers in. Ah, damn, fiddly, fiddly, fiddly. There we are. Some masking tape on there. Now this is just to loosely hold because I'm only going to do one solder joint on each header and then straighten them up. One on there. One on there. And one on there. Okay, take the masking tape off. Check the jumper will go on, which it won't. So make sure now, we got to make sure now that they're straightened when they go in. Just melt the solder, straighten them up. And we're ready to do the rest. Make sure it goes on. Yep, good. Yes, it's leaded flux core solder. Leaded solder is so much better than the new crap they use. Been using it for years. Doesn't show, but I've been using it for years. The other thing about fine soldering work is my hands are too shaky these days for it. But this is fine. This is fine. This is not a complex build by any means. The worst part about it is the ziff, as we'll see in a short while. I need a new soldering iron too. Mine has been has taken some cat damage to the wire, and sometimes the temperature sensor doesn't work. No high voltage wires are split, but it's the temperature sensor. Okay, now for the dip switches. One in again. Now get it seated properly. And the rest of them can go ahead. Corners first. Opposite corners first, then the rest can go in because it's seated. And that's that. And now for the switch. As you can see in the shadow there, I'm using pliers to tighten up the no use touching it, but the tip is loose, so I used pliers there to tighten it up. There we are. Magically appears another switch. I've forgotten I got one out. Duh! This is the reset switch. This one is quite well held into the board just by friction, but of course it has to be soldered to make a good connection. But it doesn't need masking tape to hold it there while I do solder it. And now for the most problematic part. Yeah, that's it, good. The ZIF socket. Bend back the capacitor. Move that out of the way a minute. It's tricky to get in. Really, really tricky to get in. Because it's a bit of a hodgepodge. By necessity, it's not going in, no matter what I try. Not lining up. Now I really didn't want to take it out of the ZIF socket because it was fun getting it in there. These are little things, but I'm going to I think I'm going to have to. Let's straighten them first. We'll try straightening them all first. They're not really out of shape, but these tiny holes and these tiny pins just do not want to line up. And there's no cutscenes here, no bloopers, they're all in the reel. Come on, line up, line up. No, 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 not lining up, not lining up. This is the longest part of the build. No, come on, get in there. No, no. Spoiler alert, it doesn't work. Plan B. Notice I'm not using any force here. That would be a bad thing. Okay. What I did with the ZIF socket is because they're sort of rectangular pins and they're in line with the ZIF socket, I had to bend them all 90 degrees. So they were perpendicular to the ZIF socket. Okay, so I'm going to get these in here now. These are tricky because they've been cut to fit the size. Now we need to straighten them again. Get in there. Masking tape. These are really tricky. This is the worst part of the build. See, putting a normal socket in, when I first built a cartridge, with a normal socket was easy. This isn't. The normal sockets have round holes, which again were no good for the ZIF socket. Of course, all this height makes it too big to fit in the Commodore 64's cartridge port, but more on that during the testing, in which you will see I use an expander. Okay, just get the edges in first, and it doesn't quite work as planned. It sort of moves the pins in, but we'll sort that out in a short while and check. Okay. Hold them into place and get them all lined up nice. And solder the rest. Now as it happens, it didn't really matter or the push pins, because as long as they make a good contact, that's all that's needed. Okay, make sure they're all done, all clean solder joints, and I'll do the other one. More solder. Of course, the biggest solder project I've done was the LED cube, in which I ran out of solder and had to order more. Okay. Now here I noticed that the pins are slightly out, or the sockets part. And decide to make sure they're in better. I'll bring back the board holder. Of course, I do not under any circumstances want to touch the copper on the other side while holding a soldering iron against it, because that's likely to be a bit of an ouchie. I shall heat it up. Push it in. It's not perfect, but it's better. Silly. No, not the solder. There we go, that's two done. Get the old multimeter out to do a continuity test. And that works. Check the other side. I say it doesn't have to be perfect as long as it's making connection. Yes, that's good. So, let's get the ZIF socket in. Well, this was tricky the first time I tried it, and it was separate, but easy. Easy! And there it is, cartridge complete. Got the jumpers. Oh, yeah, of course, I realised I'd got the old switch. That's when I realised I'd left the switch. Get the jumpers on. Not to keep warm. It's not that sort of jumper. There we go, all complete. Now let's do some flashing. Okay, so we built the cart. Now we're going to flash the chip. What I have here is a WC 27512 electrically erasable PROM. I'm going to pop that in the programmer. First thing we'll do is an ID check to check that all the pins are in, which they are. You've got good read device there. Now I'm going to load what I'm going to put on here. The first thing I'm going to load is a dead test cartridge. You can't see, I'm afraid, the loading dialog, but I'm not upset with that. So we're going to go with the defaults here: clear buffer and start at 0. That's an 8K cartridge. The next one we're going to load is my own game, Cruising on Broadway. But we don't want to clear the buffer this time, so we'll disable that and we'll start at hex 2000, which is 8K on from the last one. The rest are 16K, so we'll disable that first. We're loading it at 4000, which is a further 8K on from Cruising on Broadway. We will load Beam Rider onto there, and then we will load, after disabling that, and into hex 8000. Ooh, don't want that many zeros. Into hex 8000 we are going to load Gyrus. And finally, disable clearing the buffer. We want to go into C000 and we want Hero. So that's that built. I'm going to save it. Save it as devcart. Yes, you didn't see that. Doesn't matter. Doesn't matter. And now we're going to flash it. We hit program and program again. This takes a few seconds. It's not overly long. It's not slow. As you can see, the progress bar is going up. It's only writing 64K. We're at 50% already. There's lights flashing here, but here we are. You can see it if I do that. When the flash finishes, the yellow light will go off. The red light just says, yes, we're operational. And there we go. Lights off. Programming succeeded. Now, on to the testing. And so the testing begins. Here's the dev cart in the expander. Dip switches are set to use XROM, HIROM, and use the switches. We shall put this in now, making sure it's sat nice. If this doesn't work, then it's because it's not sat nice. In it goes. Now this is the dev test, which takes about 10 seconds to start up. Now that source input output is a little annoying, but we'll live with it. There we are, there's the dev test cartridge, so that works. Now I shall change this over. I'm going to change that XROM there and game, and I'm going to put the ROM bank select switch to there, to number 1. Swap that over to low ROM, leave that where it is, pop it back in, and here's my game. Which I have play of, however good or bad I do. Yep, we can do that now. There we are, one level of this. So that's my game. I'm going to swap. I'm going to turn this off now again, because I'm going to do some jumper swapping, and I'm also going to swap that because the rest of the game's at port 1. So we'll take this out again. I'm going to switch both of these jumpers over now to the 16K slot, and I'm going to turn the game off, and I'm going to put that in the, which is actually the second ROM bank number 2. We've had 0 and 1. 0 is the dead cart, 1 is my game. Now the least significant switch, the one on the right, no longer matters for the 16K. And that didn't work. Why? Because it's shit. Oh, no, that's 16K, that's 16K. Checking all these are set right. Checking that set right. Popping that back in again and go. There we go, that's better. See, it's just a simple matter of SIP switches sometimes. Right, for this, you start with the number keys and on the stick. I'm only going to play one level. Here we go. Wait for these to come out. Oh, damn it. There's another extra light coming in this level anyway. Now you get the number in the top left there, which says 10 is how many of these we got coming at me. There's 9 left. See, they do fire at you. It gets very difficult. With all the simple graphics on this game, it is absolutely phenomenal. One left. Oh, come on. Nah, he's gone off. Oh, he was quick across there then, wasn't he? Right, then we go. Oh, come on! There we go, go over here. Wait for those to come through. And then, oh no, miss. There we are, I've got him. So that's one level. Now for this, I'm just going to set dip switches. And press the reset button. And there's Gyrus. One level again. This is probably echoey because it's coming through on both things because I'm not doing this properly. It doesn't matter. It does a demonstration. Because the mic is going to be picking up me and it's also going to be picking up and we've also got the light in coming in and I haven't set up the audio right on this at all, but I'm not I can't be asked to do it again. One level, as I say. Now we'll switch it over to Hero. A single dip switch and a reset button, and there's Hero. Again, a single level. Actually, we do 2 levels on this because a single level is really short. And there we go, that's the testing done. Well, I hope you enjoyed that. And I'll catch you on the next one. Now the next one's going to be pretty soon. It's going to be pretty short. It's to do with an Amiga upgrade. Enjoy, and thank you again for watching. Ta-ra now.